All right, so again, we're still on the function. This function f of x is equal to so e to the power of negative x times square root of x. I just have to break it down into the different sections so as to easily answer the questions. So the next one we're doing is this one, intervals of increase and decrease. Just going to push this down. Okay, so it's easier for us. So find the intervals of increase and now intervals of increase and decrease is different from the sign of a function. Supposing we have, let's say I'm just going to use a quadratic function, which is easy to explain. Okay, now above the x-axis, the function is positive. Below the x-axis, the function is negative. When you talk about increase and decrease, now you can see here where this function is going down, that's where we have a decrease. Okay, then we have like a minimum point here. Now where the function is going up, then we have an increase. So this talks more about the direction than the position. When you talk about this, the sign of a function, is focused on the position of y or f of x on the graph. If it's above the x-axis, you have a positive value. If it's below the x-axis, you have a negative value. But for intervals of increase and decrease, you're talking about the direction. If it's going down now, it's decreasing. If it's going up, it's increasing, and then there's there are points where you have no change, just like at the minimum point, at the maximum points. Now, how do we find the intervals of increase and decrease? Okay, first of all, what we have to do is find the derivative of the function. When you find the derivative of the function, it tells you the rate of change of that function. Okay, the derivative of the function tells you the rate of change. Okay, is it going in this direction or is it going in that direction? Okay, it tells you the rate of change. So f of x, f of x is equal to e to the power of negative x dot square root of x. Now we want to find the derivative. Okay, now we have two separate functions and we'll multiply them together. So we can use the product rule. And I like to use y. So instead of using, I'll just use y because if y equals u dot v, right, then do y dx or f prime of x in want to be. Now this is how I like to do it. Okay, v du dx plus u dv dx. I like to do it this way. Although some books will write it as, some other books or some other sites write it as u dv dx plus v du dx. I prefer writing it this way because of the quotient rule too. I kind of allows me to remember the quotient rule. But this is, here we're using the product rule. Okay, so we can say, okay, so I have again y is equal to to the power of negative x dot square root of x. So let's u will be equal to e to the power of negative x, and our v will be square root of x. Then our du dx, okay, what is the derivative of e to the power of negative x is negative e to the power of negative x. Yes, okay, and then dv dx, the derivative of square root of x. I think we did that before when we got 1 over 2 root x. So we have 1 over 2 x. Now we'll have all the things we need. And then we'll know that dy dx equal to v du dx plus u dv dx. So our v is x. Okay, bracket negative e to the power of negative x plus our u is e to the power of negative x bracket 1 over 2 x. So this is a long one, okay? This seems like a long one, but we can do it. We can do it, okay? So we can open the bracket. Okay, we can open the bracket. We have negative, okay, negative square root e to the power of negative x plus e to the power of negative x over 2 root x. Now we can, this on its own looks a bit confusing because now we have to equate it to a zero, yeah? What we can do, we can factorize. What are we going to factorize? We're going to factorize e to the power of negative x over root x. Okay, so this divided by this. So let's divide this. Let's see. If we factorize this out, okay, so e to the power of x, e to the power of x, then we're left with negative x. Okay, why did I get negative x? So for the numerator, you divide. For the denominator, you multiply. So e to the power of x, divided by e to the power of x, e to the power of negative x divided by e to the power of negative x is 1. Now, since there's a denominator here, so we can multiply. So root x times negative root x will be negative x. Okay, plus e to the power of e to the power of what do you call it? E to the power of negative x divided by e to the power of negative x. Okay. Now, since this is the denominator now, we can still divide. Okay, 2 root x. So this major part is okay. All right, 2 root x divided by root x down 2. So we have, then we're going to equate this to 0. Why are we equating this to 0? Because we're looking for that point where things change. Okay, so again, it's going to be the rate of change is going to be 0 at this point. So before it now it's decreasing, after it's increasing. So knowing where it's 0 kind of gives us an allows us to know, okay, if we go towards the side of the of if we go towards the left, could be increasing or decreasing. If we go towards the right, it could be increasing or decreasing. So let's equate it to 0. Now if this is equal to 0, it means that, so this is multiplication, right? So we have e to the power of negative x over x bracket negative x plus 1 over 2 is equal to 0. So it means that since we're multiplying, it's either this is equal to 0 or this is equal to 0. So let's look at it. So it's either e to the power of negative x over root x is equal to 0, or negative x plus 1 over 2 is equal to 0. Now this cannot be equal to 0 because for this to be equal to 0, it means that the top has to be equal to 0. The bottom cannot be equal to 0 because that makes the function of this equation undefined. Okay, so it means that e to the power of x has to be equal to 0. And like we said, exponential functions don't give us 0 unless the base itself is 0, but generally they don't give us 0. So it cannot be equal to 0. Then we have negative x will be equal to, take this to the other side, negative half. So divide both sides by negative 1, or just take away the negative sign. So x is equal to half. Okay, so it means that at one of the intervals, okay, it could, so this could be a maximum point or a minimum point. We don't really know yet. We know that, intervals at a particular interval, x is equal to half. So what we're going to do now, we're going to check when x, okay, so we know that at this one, you know, f prime of x is equal to 0. We're also going to check for where, okay, we also want to know when f prime of x will be greater than 0 and where f prime of x will be less than 0. Okay, so what we do now, we check for when, we're going to check for when, sorry, check for when x is, because we know that when f of x is equal to 0, that's when x is equal to half, right? So we're going to check when, how about when x is greater than half and when x is less than half. Now, consider one more thing. Remember that for the domain of this function, let's go back up, x is greater than or equal to a 0. Okay, so in that case, even though we're going to check for when x is equal to x is less than half, it's going to be, it's more like x is less than half, and then or equal to 0. So we're going to check when x is like this and when x is greater than half. So let's see. Let's see. Okay, so we have f prime of x, which is equal to this right here. So that e to the power negative x over root x, negative x plus half. We know when x is equal to half, this is equal to 0. When x is greater than half. So let's see when x is greater than half. So I'll pick a number that's greater than half. Let's say 1. Like we plug in 1. So you can use your calculator. I will use mine. Okay, so actually let me get my calculator for this. I'll just use 1. I'll use my x as 1. So this will be e to the power of negative 1 over 1 bracket negative 1 plus half. Okay, I'm gonna put that to my calculator and tell you what I get. So we have e to the power of 1, sorry, negative 1 actually, negative 1 over the square root of 1 is 1. That's why I just put 1 there, but let me just write square root there. 1 bracket negative 1 plus 1 over 2. That gives us negative 0.183. Let's say 0.1839, so that's just 0.184. So you can see now we have a negative value for this negative. How about when x is between half and 0? What number do I pick? Do I pick 0? I mean, it could be 0 too. So I'll pick 0 here. I'll pick 0. So we have, so let me keep this. Yes, x can be 0. It's allowed. Okay. So e to the power of 0 over, oh no. Let me not do that. Let me not do that. For this one, it cannot be 0. So we can denominator to be 0. So let's say, let's pick a quarter, 1 over 4. So e to the power of negative 1 over 4 over the square root of 1 over 4 bracket 1 over 4, negative 1 over 4 plus half. Okay, so we have e to the power of negative 1 over 4. Okay, or the square root of 1 over 4. Okay. Bracket, let's see. Bracket negative 1 over 4 plus half. And I actually get a positive number here, which is 0.3 0.894, so 0.3, so this is positive. So what does this mean? So we have now the interval. Okay, so the question itself, let's go back to the question. The intervals of increase and decrease. The interval itself is at x equals half. Okay, the interval is at x equals half. All right, interval for increase and decrease at x equals half. All right, we can also write it like this. Yeah, interval. Now, if it goes above, if it goes higher than half, the function starts to decrease. If it's less, so it's more like, let's say, like this, looks something like this. So let's say where x is half. Okay, where this is x-axis, where x is half. Okay, as it goes above half, it starts to decrease. If it goes below half, that's where the function was increasing. So this interval, so it kind of answers the next question now. Find the local maximum. This is a maximum value. This at x equals half, we have a maximum value. Okay. So the interval. So again, sorry. All right. So the function is increasing at x equals half. Now someone said, how about at a zero? Because that's where the function starts. So zero, you can also consider zero as a minimum point because the domain of the function is, so like I said, the graph looks something like this. So we can say that this point here will be at x equals half. Okay, we can have a minimum point at, okay, so let's see. Um, so the interval, so sorry, so for the interval of this, go back there. The intervals are increase and decrease. So when x, you can say, so f of x, oh sorry, I'm just doing this. Okay, so I'm just gonna write here for when f prime of x is equal to 0 at x equal to half. Okay, f prime of x is greater than 0 at where at the interval where between x half 0. So we can write it like this in bracket notation form. We have 0, then 1 over 2, not included. And then f prime of x is less than 0 when x is greater than half. That's where we have half like this, and then infinity. So these are the intervals. So this will be the intervals for this function. Okay, the intervals of increase and decrease. So at this, it's 0. It increases here, and it decreases here. It's a long one, but then then since we've been able to decide that it increases before x is equal to half and increases and decreases after x is equal to half. You can answer the next one and say find the local maxima and minimum values. So the local maxima here will be half, where x is equal to half. Okay, x is equal to half. And then we can also put the minimum value at x is equal to 0. So maximum value at x is equal to half, minimum value at where x is equal to 0. Why? Because this will have f of x is equal to e to the power of negative x dot square root of x. This is always a positive function, so it can never be 0 again. It can never reach 0. We have said we have an asymptote at 0. So it starts from 0, yeah, fair enough, goes up, then kind of goes like this. So the lowest possible value was the beginning at 0. The highest possible value was here at x equals half, and then it just keeps going like this, just keep going down, down, closer to 0, closer to 0, but never actually hits 0 again. So we say the local max. So this is the absolute maximum. It's the absolute maximum value. This is the absolute minimum value. Okay, so yeah, this is it. I hope I've been able to explain this concept well. It's not. I know it takes a while to get used to, but I really hope it helps. Thank you and have a nice day. Bye bye.